Hello everyone. So we are going to start a new topic, that is the deformation of solid. So this topic has been divided into different parts. So we are going to start the part 1 today. So without wasting any time, let's start the topic deformation of solid. So if you see the background, let's have some basic idea regarding the deformation of the solid. First of all, you see it is possible. It is always possible to change the shape as well as the size, or sometimes you can change both the shape and size of an object by application of an external force, right? If you have some object in your hand, if you apply some pressure, or you can apply some force, external force, then definitely the subject may either change in its shape or in its size, or sometimes both. So this changes, actually it is explained as the strain. The changes which occurs in shape as well as in the size or in the both by application of an external stress, or you can say external force, it is known as the strain. Now as the deformation it occurs, you should know that this substance in which we want to induce an external change, right, this substance, they also have internal intermolecular forces, and as the deformation it occurs upon application of the external force, the internal intermolecular forces they arises, and these internal intermolecular forces they always oppose the applied force. They always, I repeat, the internal intermolecular forces they always oppose the applied external forces to induce the deformation. Clear? Now you see, if the applied force is not too great, means if it is not too high, then these internal forces are sufficient to completely resist any changes. Suppose if the internal intermolecular forces of the solid substance or of the substance it is more as compared to that of the external force that you have applied, then the solid substance or the substance will resist any change, right, that is applied by the external forces, and allow the subject to assume a new equilibrium state and to return to its original state when the load is removed. I repeat this. Suppose we have something in our hand, right, a solid piece of material. Now if we have tried to deform the shape or the size of the substance, and if the intermolecular forces of the substance is more as compared to that of the applied external force, then definitely the substance will return back to its original state upon the removing the external force. Clear? So a larger applied force may be lead to the permanent deformation of the substance, or even sometimes it can lead to the structure failure. Suppose we have applied a greater force to the solid substance. I repeat, suppose we have applied a greater force to the substance, and if this external force which we are applying over the surface or over the surface of the solid, then if this force it is more as compared to that of the internal intermolecular forces, then there will be definite permanent change in the structure, and this is also known as the structural failure. So depending upon the type of the material, its size, its geometry, the force applied causes various deformation. They may cause various deformation over the surface of the solid. Now elasticity of solid. So you see, the definition is that what is elasticity? It is the property of any material. Elasticity can be defined as the property of any material which actually helps them to return to their original dimension when you have removed the force applied upon them. I repeat, suppose we have a rubber band, right? If we pull the two end of a rubber band with both our hands, and upon releasing the rubber band from this two end, this rubber band, they generally come back to its original state. That is the elasticity. Elasticity, it is an inherent property of a material which helps them to return into their original dimension. Dimension includes both the size and shape after removal of the external applied force. Done. So the deformation occurs when external forces act to stretch, compress or shear a solid. Now the deformation of the solid, deformation of the shape of the solid or deformation of the size of the solid, it occurs only when this applied external force, they have the capacity to stretch, compress or shear a solid substance. Clear? So you see, an object or a material which return to its original length or size after being distorted, they generally suffer from elastic deformation. That is, it behaves within the elastic limit. I repeat, suppose we have a rubber band. If we pull the both end of the rubber band and if we pull it, it will stretch, but after removing the force or after releasing the rubber band, it will come back to its original position. So that is the elastic deformation, and this elastic deformation, it occurs within the elastic limit. But if we cross the elastic limit, what will happen? The rubber band will get break, right? So now plastic deformation occurs when the material is deformed beyond its elastic limit. So plastic deformation occurs when the rubber band, it is pulled beyond its elastic limit. So you see, the behavior of a material under the deformation can be explained by following mechanical properties. What are the mechanical properties? They are shown by a material upon application of an external force. First property, it is the strength. So strength can be described as it is the ability of the material to withstand a force without breaking. It is the strength, it is the inherent power of the solid substance to resist any change in the dimension, that may be either your shape or size, upon application of an external force without the breaking. Next property, mechanical property, it is the stiffness. So stiffness can be defined as the resistance of a material to change in the shape and size. Stiffness, it is the resistance of a material to the changes in shape as well as in the size. The next one, you know, elasticity. Then the next one, it is the ductility. So what do you mean by ductility? Ductility, it is the tendency of a material to change its shape and size considerably before breaking. Ductility, I repeat, it is the tendency of a material to change its size and shape. Suppose we have pulled the rubber band, right? Now the shape of the rubber band, earlier that may be a thick one or a bigger one. Upon pulling, it will become a leaner one or thinner one, right? So this is the ductility. This is the tendency of a material to change its size as well as the shape considerably before the breaking. And the last one, it is a brittleness. So brittleness, what is brittleness? It is the tendency of the material to break without the deforming. So there are some material which generally breaks without deforming upon application of an external force. So this is the brittleness characteristic of a solid material. So the next concept, it is the stress and strain. So stress, it can be defined as the force that is applied per unit cross-sectional area, F by A, that is the stress on a body that tends to cause or to deform. So stress, it is F by A. So you see, stress, it is denoted as a F by A, where stress, it is shown by the sigma, right? F, it is the force, or you can say the force, the applied force, and A, it is the cross-sectional area on which the force it is applied. Now you should know that the stress, it is a scalar quantity, and the dimension of the stress can be given as like this: stress is equal to F by A, force is equal to ML inverse, 2 inverse divided by L square. So simply the unit of the stress are kg from the mass, L it is the length, right, per meter, T it is the time, per second square, or you can say it simply Pascal. Now strain. So strain, It can be defined as a fractional change in the dimension of the object. Strain, it is the change in the dimension of an object upon application of an external stress. So strain, it is also a scalar quantity and it is dimensionless. So the stress strain can be classified into basically three types. The first type of stress strain, it is the tensile and compressive stress strain. For type 1, it is the tensile and compressive stress strain. Type 2, it is the bulk stress strain. Type 3, it is the shear stress strain. So let's study them one after another. So the first one, it is the tensile and compressive stress and strain. So what is that? So let us consider this is a rod. Here we have applied the force. This is the F force. It is this force, we are pulling this side of the rod towards this direction, the other side of the rod it is pulled in this direction. The force F. A, it is the area of the cross section where the force it is applied. L naught, it is the initial length. L naught, it is the initial length of the rod, but after application of the force the rod will be extended, and suppose it is new length become here, it has extended to this portion. This new length, it is denoted with small e. So you suppose, let us consider a rod that is initially has a uniform cross sectional area A. Initial length, it is L naught. The rod, it is stretched by applying forces of equal magnitude at the both end, right, but in the opposite direction. The rod will extend by an amount E as shown in the figure. Now from this we are going to get the stress and the strain. So the tensile stress, here the tensile stress, it is defined as the ratio of the perpendicular force F divided by cross sectional area. Tensile stress, here it is F by A, where F, it is the force act perpendicular to the cross section and A, it is the cross sectional area. Now the tensile strain, what is the tensile strain? It is the change in, or it is strain, it is the change of the, or you can say it is the change in the size and shape after deformation. So tensile strain, it is defined as the ratio of the extension E to the original length L naught. Tensile strain is equal to E, change in the stress, you say change in the length by the original length. So E can be also written as L minus L naught. L, it is the final length, L naught, it is the initial length divided by L naught. So E, it is the extension is equal to the final length minus the original length divided by the original length. The next part, it is the compressive stress strain. Now here the force, it will try to compress the rod, right? Similarly we have the same experiment. Here now you see the force, it will be applied in this direction. Similarly here also it will be applied in this direction. So both these forces are trying to compress the rod in this way. Now the A, it is the area of the cross sectional area. L naught, it is the initial length of the rod, and E, small e, it is the extent of compression. Small e, it is the extent of compression. So from here also we are going to get the compressive stress is equal to F by A, whereas the compressive strain is equal to E by L naught, where L, it is the final length, L naught, it is the original length divided by L naught, it is the original length. The next one, it is the bulk, or you can say bulk or volume stress strain. What is that? So let us suppose there is a sphere. This is a sphere, right, which is having a initial volume of V naught, and it has been immersed in a fluid. This fluid may be either your liquid or gas. Now this fluid, it is going to apply force over the surface, over the volume of the sphere, right? So the fluid, it exerts any the force at any part of the object. Now this force, it is perpendicular to the surface, right? This force, it is F, and it makes the sphere decrease in the volume. Initial volume was in the, this was the initial volume, and this one shown in the dark color, it is the final volume. So the difference in the volume, it is shown in the figure. So here the bulk volume or stress, the bulk or the volume stress, here it is defined as the force per unit area that the fluid will exert over the surface of the immersed object. The bulk stress, it is same, only F by A, it is also, it is represented as delta P. Delta P, it is the change in the pressure, and where A, it is the surface area of the sphere that is immersed in the liquid or in the gas. Now the bulk strain, it is defined as the ratio of the change of the volume, that is denoted with delta V, to the original volume V naught. So bulk strain, it is equal to delta V by V naught. Delta V can be written as V, it is the final volume, and V naught, it is the initial volume, divided by V naught, it is the initial volume. So delta V, it is the change in the volume, V, it is the final volume, and V naught, it is the initial volume. So thank you everyone, hope you have liked the video. If you like the video, just press the like icon. You can share this video, you can subscribe to my channel. Thank you once again.